Hey, this is James Con, and today we're going to implement a blur shader that blurs the entire screen. And what we're going to end up with is an effect like this, where we press the escape button. Let's say you have a menu that pops up, and if you notice, all the background is blurred now. The whole 3D scene is blurred, and you'll see that in games a lot, and it's kind of a nice effect when you're displaying a UI element. And there's other reasons you might want to use a blur shader. If you're implementing a bloom effect, then blur, you would want to have a blur shader for that as well. A ton of different reasons you might want to have a blur shader. So that's what we're going to work on today. We're going to use the project from the first video about frame buffers. So if you haven't seen that video yet, I recommend you go through that video first, because we're going to take that knowledge from the frame buffer video and use that to create this blur shader. So I do want to mention one thing from the previous frame buffer video. When I use this GL30 to use the GL depth component 24-bit to give us better precision, particularly for 3D scenes, it's kind of a hack. It's a workaround, I would say, because my GPU supports OpenGL3, we can use this. Even though libGDX, we haven't actually enabled the OpenGL3. But ideally, if you're going to use this, if you're going to use any GL30 values, you would want to come in here and set up your OpenGL emulation to use version 3. So I just wanted to mention that. It's kind of a hack what I'm doing right now, but now that that's out of the way, we can get started. Right now we're rendering our 3D scene and capturing that inside a frame buffer. Then we're taking the texture from the frame buffer and drawing that with a SpriteBatch. So the next step is going to be to create our blur shader, and we're going to use SpriteBatch for that for simplicity's sake, because you can actually set a custom shader on the SpriteBatch. Now another way you could do this is rendering to a 2D quad, a full screen quad, but since most people are familiar with SpriteBatch, that's what I'm going to go ahead and use for this video. So to get our shader created, whenever I'm using the SpriteBatch but making a custom shader, I always do this little trick here. Because if we look at the SpriteBatch, we can see the default shader code that SpriteBatch uses. However, it's all in Java strings. It's embedded in the Java code. And if I wanted to copy that and paste it into a file, I'd have to remove all these other values that we don't want, the quotes and the escape characters and all that. So instead, what we can do is we can get the default shader this way. And, I always say work smarter, not harder. So I'm just going to print out the shader code, and it's going to print it out in the logs nice and pretty for me. So let's run that. And then we'll grab this will be our vertex shader code. And so now if I go to our assets directory, I'm going to create a new directory called shaders. And then we'll create a new file. And that's going to be blur.vert. That'll be our vertex shader. And then let's do the same thing now for the fragment shader. Here we go. Copy all of that. And let's create that file as well. So we'll call it blur.frag. And paste it in. So now we have the same code that the SpriteBatch uses by default. And so what we have to do is we have to build a shader based on that. And that's going to be a shader program. So let's come up here. And just down below our FBO, we'll go private shader program, blur shader. And now to build that, we'll come down to... where do we want to build that? We'll probably build it right around where we create the SpriteBatch here. So we'll say blur shader equals, and then we'll create a new method called build shader, and we're going to pass in the path to the shader files that we just created. I think it's actually shaders. Let me fix that. Blur.frag. Okay. And let's create that method. Alt-enter, create the method. And I got the code ready. I'm just going to bring it over. It's pretty standard boilerplate code. And so we're just going to call these vertex and fragment path. And all we're doing here is we're getting the actual string values. We're reading the string values of these two files. Then we just create this new shader program. And we check if it's compiled. If it's not, then we'll throw an error and log it. Otherwise, we'll return the program. So that's going to build our blur shader. All right, and now what I'm going to do is we'll say SpriteBatch set shader, and we'll set it to use the new blur shader that we just created. Now it should look exactly the same, but I just want to do this to make sure that, hey, our shader's working and it's compiling and everything. And so if we look here, this should now be using the custom shader that we just created. A quick way to make sure that this custom shader is being used is we could just take the fragment color here in our frag shader and set the red to 1.0. And if we run that, we should have like a very much a lot of red color going on. And so we do. So that's just one quick way to make sure that, you know, hey, yeah, it is in fact using this shader instead of the default SpriteBatch shader. So we're good to go there. Let's undo that. And so if we go back, so now we're using this custom shader, which is great. But we're not doing any kind of blurring or anything like that yet. So that's what we will work on now. And what I'm going to use for that is a tutorial here from Matt. He's done a bunch of LWJGL and libGDX tutorials as well. He has one here, Shader Lesson 5, on just creating a kind of simple blur shader. It's very handy. It works good on desktops. On Android, I'll show you a couple tweaks that we can do to try and make it a little more performant. There's also an alternative to this blur technique here. If you're having performance troubles, then you might want to look down here for OpenGLES and low-end hardware. For the sake of simplicity, and because we want to use frame buffers and shaders on this tutorial video, we're going to be using this version. Plus, I'm running it on a desktop computer, so performance shouldn't be much of an issue. Now, if you want to understand the shader better, I highly recommend reading through this article as it goes into detail about the implementation. But the general gist is we're going to do two rendering passes. We're going to do a horizontal blur, and then we're going to do a separate vertical blur. And then we'll probably do some ping pong between those frame buffers as well. I'll talk about that when we get there. But yes, highly recommend reading through the article because I'm going to kind of jump through this quickly and just implement the shader for the sake of keeping this video short. What we need to do now is set up two frame buffers for our two passes, our horizontal and vertical pass. So we'll create them here. We'll say blur target A, duplicate that, blur target B. So now we have two frame buffers to hold those two passes. And next up, we'll probably want to set up, well, yeah, actually, let's go ahead and create these frame buffers now. So we have that build FBO method. And, you know, for this frame buffer that captures a 3D scene, we needed this additional depth. But for the blur frame buffers, they're 2D. We're passing in textures to them. So they don't need the additional depth. We can just use the standard frame buffer constructor. So we'll just say new frame buffer. Let's grab this format, pass in our width and height. In false, we don't need depth for these blur frame buffers. All right, we'll change that to B. So now we have our two new FBOs here, and I'm going to duplicate this twice. Oops. Duplicate this twice so we can dispose of them. If, you know, on a resize, we have to rebuild these. So let's just make sure that we're disposing of them. And then real quick, I'm actually going to fix an issue from the first video where if you minimize, I actually hadn't encountered this before, and I just happened to find it by accident. If you minimize the screen, it actually crashes. The game crashes, and if you look at the logs, the frame buffer couldn't be constructed. And that ends up being because when you minimize the screen, resize gets called and the width and height is 0. There's probably different ways to fix this. The quick fix that I'm implementing here is just checking if width is equal to 0 or height is equal to 0. Then I'm just going to return. We're not going to rebuild the frame buffer. And if I try this again and minimize it, I can open it back up. It doesn't crash. So that's just a quick fix for that right there. Okay, so next up, we're going to get started on bringing over the shader code from the tutorial. So if I bring that tutorial back up, and we find the fragment shader here. Here's the fragment shader code. I'm just going to go ahead and copy all of this. And we'll bring that over. We'll have to make a few small changes. So in our fragment shader, I want to keep everything up here at the top. I'm just removing that main method. I'll paste. And a couple things. So we already have a color in TextCord, part of the SpriteBatch's default code. So we'll just replace these. We're going to get rid of them, but first we need to replace them. So let's just replace vColor with v_color. And then we can remove it. And then we'll replace vTextCord with v_textCord. Replace. And now we can remove that as well. We've already defined uTexture here, so we can pull out this one. And then we just have these 3 new uniforms that we're going to have to pass in our code. And I think that's all we need to do for now. I think we'll be fine. So let's go back to our code. And we can start changing a couple things in our render loop here. I'm going to take the code that renders our 3D scene and move it into a different method. Just to clean it up, because we'll probably be calling this code potentially multiple times later, depending on if we're blurring or if we're not blurring. And next up, we can start. I think we're ready to start capturing these textures now into our blur target A and B frame buffers. So let's go down a line. We'll say blur target A.begin, just like we do with this FBO here. We're going to start the blur FBO. And then we can say SpriteBatch begin, because we're going to use SpriteBatch to render the texture. And let's just go ahead and end these now too. There we go. And at the top, I'm going to put a comment here: horizontal blur pass. And then we're going to go SpriteBatch, draw. We're going to draw the FBO texture that we got. So that's going to be our 3D color buffer texture. And we're just going to go 0, 0. Actually, I think we can copy this exact same code here. Okay, there we go. So, okay, we got our blur target A drawing the texture to be blurred, but we also have to set those 3 new uniform variables. So let's do that now. SpriteBatch, not on SpriteBatch, but on our blur shader actually. Now the beautiful thing about this shader is that we can use the exact same shader code for both passes. We don't have to have 2 different shaders, a horizontal and a vertical blur shader, which is nice. So we'll say set uniform F, we'll do direction, and 1, 0. Because this is our horizontal pass, we're going to set the direction to 1 on the X axis. And then let's copy that. Next one's going to be our radius. And for that, we're actually going to set up where we take the mouse position and we use that to control how much we're blurring and how much of the vertical blur, how much of the horizontal blur. It's kind of neat. It's what's being done in this tutorial here. The code is kind of like a generic code for the mouse, this mouse amount here. But what I've already converted this code to be compatible with libGDX, so I'm just going to copy that over. Here we go. So let's take it right here. So what we have is this. Let me get rid of that side panel. Determine the radius of the blur based on our mouse position. We'll take this mouse X amount, since we're working on the X axis here, and pop that in. Pop that in there, and we're going to times it by a new value that we're going to define at the top. It's going to be a float. We'll call it max blur. You want to limit the blur and we might see that later. The shader has a predefined amount of samples. You'll see some blur shaders, and if you can dig into this, there are a ton of different examples of blur shaders out there. This is just the one I happen to go with because I know it's very easy to convert over. But this shader has a predefined amount of texture samples that it's going to do, so it's going to be limited, right? It's going to be limited on how much sampling it can do, and if you try to blur too much, you're going to get noticeable like lines and squares, almost like pixels, because you're going over the limits of the shader. But we'll talk about ways to improve that later on. So now if we go back down to our code, where were we? Here we are. We take that mouse X amount, times it by our max blur. And then we got one more to set up here. That's our resolution. And we'll take the width of our screen as the value that we're going to set for that one. Okay, direction, radius, and resolution. There we go. And we pass in the texture. So now we're not going to draw to the screen. We're not going to draw the original FBO color texture of the 3D scene. We're going to take, for now, we're just going to do the horizontal texture. Let's do so let's get that color buffer texture from the blur target A frame buffer. Oh, hold on here. That doesn't look right. Okay, I made a mistake. So radius as a single float, we should be passing in 2 values there. Let me try that again. That was it. Alrighty. So here is our horizontal blur, and you'll see that the blur continues the further to the right the mouse goes. And it's not very smooth looking right now. We'll clean that up later. It is blurring it though, but you can see maybe, I don't know if you could see it well on the video, but there is some kind of like little artifacts that are visible, little lines. It's not a very smooth looking blur, but it's a start. Let's close that out. And I'm going to copy and paste this code now so we can do our vertical pass. We're going to change that to use the Y direction as 1. And we want mouse Y amount. So I'll make this code available. I know I kind of copy pasted this over. But the gist is that we're getting the mouse position, dividing it by the screen's width or the screen's height. And so let's take this mouse Y amount, plug that in. And now this is going to be the height for our vertical blur pass. And then this is going to take in the blur target's color buffer texture. So what we're doing is we're running our horizontal pass, blurring it, and then on our vertical pass we're taking that blurred image from the first frame buffer, or the the horizontal frame buffer, passing that image into our vertical frame buffer, and we're going to blur it now in the vertical. And then lastly we'll take oops, we got to update these to be target B. I don't want to forget that. Now, lastly, we're going to take the image output from the vertical pass and render that. So now we should be getting both the horizontal and vertical blurs. Okay, so if I bring the mouse to the bottom left, we're not really applying any blur. If I just go straight up the Y-axis, now we can see that the vertical blur is applying. And if we go back down all the way to the right, there's our horizontal. If we come up to the top right, now we have both the horizontal and vertical blurs being applied. And now we can smooth this up more. So I'll show you how to do that because we still have those kind of artifacts. So let's try to see if we can clean that up a bit. To get a higher quality blur, we're going to do something called ping pong. So we're going to do a ping pong of the frame buffers, and I'll show you what that looks like. We're going to create a new integer at the top, call it ping pong count. We'll just set it to 4 for now. And as you're implementing this, depending on device you're targeting, you might want to change these values, maybe depending on what the device is, to change the quality of the blur. The higher this value is, the more taxing it's going to be on the GPU. So let's take that ping pong count and come back down here, and we're going to clean up this code here. So we're going to create a new method. Let's go up a bit. And we'll say texture blurred result equals blur texture. And that's going to we're going to pass in a texture that we want to be blurred. And that's going to be our 3D scene, our 3D scene's color buffer. Now let's Alt Enter, create this method, and then we're going to copy all of this code, and we're going to move it to our blur texture method. Let's come back up here, and now we're going to take blurred result and pass that into our SpriteBatch to draw. So that means this method needs to return a texture. And so to do that, we're going to return the result of the blur target B. So we'll go return blur target B dot get color buffer texture. And then what we're gonna do is wrap this in a for loop. So we'll go for I equals 0, I less than our ping pong count, I plus plus. There we go. And we'll have to make a couple other small changes here. We have this issue here, so we get this FBO text being passed in. But what we're going to do now is, if you haven't figured it out yet, we're going to bounce between these two frame buffers a few times. So we're going to blur it horizontally, blur it vertically, and then we're going to loop back and blur it again and again. And the more you blur it, the more smooth that blur is going to become, but at the cost of more performance. So that's just something to keep in mind. You will want to tweak these values to get them to a nice blur that still runs okay. And so to do that, we have to change something here, right? For the first frame, or for the first loop, we do need to use the texture that was passed in. After that first loop, though, we need to start using blur target B, right? Because we're ping-ponging the two back and forth. So we can do that by just going I equal to, we can use a ternary operator. So we can say I equal to 0 if it's the first loop. Use the FBO texture that was passed in. Else, use blur target B's color buffer texture. And so now this is going to create a nice loop here where we just bounce between them. So say ping pong count, that was, we did that at 4. And we can try to run it now and see. There's probably one other change we'll make, but let's just run it as is first. Make sure everything's working. And I'm also going to make one other change here. We're going to say SpriteBatch.set shader, blur shader. After we've done our blurring, we're going to set the SpriteBatch back to its original shader. But we don't have that saved yet, so let's do that now. So we'll change this to default shader. So I'm creating a new variable here to hold the default shader. And right after we create the SpriteBatch, we can say default shader equals SpriteBatch.getShader. Because in the next two lines, we're actually replacing that with the blur shader. Actually, we probably don't need to do that now, because our blur method is going to do that for us. But now we have the default shader saved. So we come down here. Now we can set it back to default. So anytime we call this blur method, we want it to be self-sufficient. It sets the right shader, blurs the texture, and then returns the shader back to default. So that looks pretty good. Let's try to run this, see if it works. Okay. It looks a little better. There's much less artifacting going on. If we close that, we can make another change. We can actually reduce this direction to 0.5. Now this direction will reduce how far off we are sampling. And so yeah, if we take a look at the blur fragment shader again, that direction, X and Y, it's being used for kind of like an offset of our texture coordinate lookup, because we're looking a little bit off to create the blur. And so we're offsetting that. And so if we reduce how far the offset is, as the blur gets more blurred, it's going to not look so pixely and hopefully clear up those lines a little bit, because we're not stepping as far away. But again, All of this is kind of like quality settings that you'd want to change based on your device and what kind of performance targets you're trying to reach. So let's take another look at it now. And again, it might not be as clear on a recorded video, but this blur looks much better than it did before we did the ping pong and before we changed that direction to be a half, 0.5. I'm happy with this for now with this value, so let's go with that. And if you remember at the beginning of this video, I kind of showed, well, what if we want to display a UI element? Because I think right now we've met the requirements of this tutorial video. You now know how to blur a texture and how to draw that on the screen. So the rest of this content is probably kind of bonus content. I will say one other thing. When I tested this blur shader out on my Android phone, it's a 2017 phone, it's a little bit older, I was getting about 30 FPS. There's one other thing you could try to do if you don't want to try that low hardware fix or change on the on that tutorial that we're looking at. You could try another simple change, which is just to reduce the size of these blur frame buffers. And what that could look like is if we go blur scale, by default it would be 1, right? But if we take this to 0.5, because when you're blurring a screen, it doesn't matter if you're using a lower texture, because it's not going to, it doesn't matter as much, right? No one's going to see the pixelated image because you're blurring it anyways. So if you're trying to really get some better performance out of this, you could reduce the size of the blur frame buffers. And that means it's less pixels that the shaders have to go through, right? Because when you're running this vertex fragment shader, you're going through each pixel and you're sampling. Well, if your frame buffer is smaller, you're doing less sampling. And since we're blurring the image anyways, do we really need to be blurring the full screen, the full size of the application, or can we take it in half and blur that? And if we run it, the blur still looks okay. But if I run that on my phone, I actually got 60 FPS just by making that change. Now, when the blur is completely off, it does look more pixelated because it's a lower resolution. But if you're only applying the blur like when a menu is on the screen, then it shouldn't matter. So that's just one little tip there. If you may be able to use that to get some better performance out of this blur. I'll keep it at 1 for now because I'm running this on a desktop, so I just want nice looking blur, but just keep that in mind. So if you want to stick around for the bonus content, now I'm going to show what I did to get that nice kind of gradual blur effect when the menu is on the screen. And so to do that, I'm going to grab this image that I got. It's just a little example GUI image. It was a public domain licensed image that I got from OpenGameArt. I'm just grabbing that real quick. Here we go. So let's go to our assets directory and I'm going to paste that in. Again, you can use any image for this. It's just for example. And then in our code, let's get a texture for that. So we'll just go private texture. Now, if you're actually rendering your GUI, you're going to probably be using a stage and UI widgets. But for the sake of an example, I'm just going to render it as a regular old texture on SpriteBatch. So let's do that. And I'm going to try to save some time. Let me just copy and paste some code here. There we go. So in our constructor, we'll go ahead and create that texture. So GUI texture equals new texture. And then there's our GUI.png. And I'm going to create another variable at the top. And we'll just create a Boolean to keep track of if the game is, we'll call it paused, right? This is all just kind of a simulation here. But we'll say paused equals false by default. And if we come down to our render loop, I'm going to copy and paste in some code here. If we press escape, we'll set paused to, we'll basically toggle it on or off. So we'll reverse it. And actually I'm going to create this float here called a delta blur. And we'll start it at 0. And how this is going to work is back in our render loop, we'll say if paused, then we're going to pretty much wrap all this code in that if pause statement. Else, render the scene normally without the FBO, right? So there's no reason, especially this is great because then we still have our multi-sampling in this case, and we're only switching to the FBO when we're blurring it, so then you won't even notice that the multi-sampling isn't there anymore. And now if we want to go, let's go down to our blur texture method, because we're going to have to implement this delta blur. And of course, we probably don't want the blur to, let me just test, let me press escape. We probably don't want the blur to change based on the mouse position anymore, right? If we're simulating that this is when like a GUI is on the screen. So we can comment this out for now. Then we can say if delta blur is less than 1, we'll increment it by the delta time. Plus equals delta time. And now instead of using the mouse amount, we'll use this delta blur amount instead. And since our delta blur is being reset to 0 every time we press escape, that kind of resets our blur increment. So if we try to run it now, and I press escape, we'll see that gradual blur that happens, which is kind of cool effect that goes on there. And then lastly, we want to go ahead and render that UI texture just so we can make sure that it's not being blurred. And so that's why we have to reset the SpriteBatch to the default shader, because if we didn't do that, then we'd end up applying the blur here when we render our UI texture. So let's just change that to GUI texture, and this is just some code to center that texture in the middle of the screen. We run that again. Press escape. There's the texture, it looks clean, whereas the background is blurred. And then if you wanted to change the speed of that blur effect, all you have to do is go to where you're incrementing the delta blur. Let's see, where are you at? There you are, in our blur texture. If you want to slow it down, you can times it by 0.25. And now it blurs a lot slower. You can tinker with that. So I think we'll stop the video here. I hope this was helpful, and I'd ask, please, if you watch the video, subscribe. I'm working, that number is slowly increasing, and I appreciate everyone that subscribes to the videos. I know probably a good 80 to 90% of those who watch the videos are not subscribers, so please do subscribe if you want to keep seeing more videos. It's the only thing that kind of motivates me to keep making these. So I appreciate it, and we'll stop here. Thanks.